Okay, I want to go over the true-false problems because a lot of you seem to be having struggle. There was an error on the answer key for part A. Really, your sheets, I believe, show that as 1 plus. So -1 to the right, so it makes it a lot easier. So let's go through and decide if these are true or false. So I find -1. I go to the right side and I start approaching it. My y value is 1, so this indeed is true. I now find 0. Here's my 0 on the number line. I want to be on the left side and I want to approach it. As I approach it, I'm indeed 0, so this is true. Problem C, it said again, go to your 0, go to the left side. As I approach, I should be 0. So the answer that we see here, this is C. This is, excuse me, in error. And so I could fix this and I could get extra credit by giving the correct answer. The original statement is false, but the correct answer would make it true. So now I go to problem D, and when I'm looking at problem D, it says that the limit as I approach 0 from the left equals the limit as I approach 0 from the right. So here's the left side, I'm going to 0. Here's the right side, I'm going to 0. Yes, those equal the same number, so this indeed is true. I go to part E. It says that the limit as I approach 0 exists. Indeed, it does, because we've just shown that these two are equal. Therefore, it exists. Also, looking at the picture, you can see that this is a hole. In other words, there's a connection to the hole on the left, a connection to the hole on the right. So it's not continuous, but a hole. So this is true. So then we go to F. It said the limit as x approaches 0 of f of x is 0. I can look from both sides. We've already shown that here. It's true. So that's true. All of these are giving me the same answer, just saying them in a different way. I go to G. And in G, it says the limit as I approach 0 is 1. Well, that indeed is false. The limit as I approach 0 is 0. So I would have to label it false. I could correct it for extra credit. What is it that is going to be 1 is the function value. F of 0 is 1. That is the realized closed point on the graph is 0, 1. What is the whole? The whole, which would be written this way, would have coordinates 0, 0. Okay, so then we're on to the next one, H. So looking at H, it says the limit as x approaches 1 is 1. Well, as I approach 1 from the left, I'm 1. I approach 1 from the right, I'm 0. I can see these two are totally disconnected. The left side doesn't connect to the right side with an open or a closed circle. This is a jump, so the limit does not indeed exist. And so this is false. So there is, what we would have to say is this is false, and the limit does not exist because we can see it's a jump. Now, how else could have I fixed this? I could have fixed this by simply taking the spot here that's open and putting O from the left. And yes, the limit as I approach from the left side would indeed be 1. So those would be two possible fixer-uppers that would give you extra credit. So then moving to problem I, it says the limit as I approach 1 is 0. Now from the right it is 0, but from the left it's 1. So again, this one is not true. This one again is impossible. It's D and E because it's a jump. But I could indeed fix it up because you will notice from the right, if I put a little plus there, like I did here, then indeed it is 0, and I've now made it true. But as written, it is indeed false. Let's go to the last one. The last one says the limit as I approach 2 from the left is 2. Oh, now this is where people get gotten all the time. This is a very common error. Remember, this ordered pair here is 1, 0. This ordered pair is 2, 0. So the limit as I approach 2 from the left is not the x value, but the y value, and so that would be the correction. So hopefully this helps make sense out of some of the true-false issues that you all seem to be having.